These are way too long. I just buy something like
Okay, kids. Let's start with a question here today. If I told you I had a cross section right here, this was a flat cross section right here. It's an intersection of something and something else. What cross sectional shape would you say this probably is? It's a triangle, right? Now if I took this triangle like this right here and I said, you know what? Let's take that cross section and let's start to do something that's going to be, well, they're going to say start revolving it around what's known as an axis of rotation. Kids, if I do this, and I do it correctly, I'm trying to do it well. If I take this triangle right here and I start rotating it around an axis of reflection, an axis of rotation like this, can you kind of visualize what shape that's going to form? It would be circular, right?
A cone.
That would be a cone shape, right? Everybody see that? Okay, so I can try and spin it really.
Look, that's gone. I see it.
You see it now?
Yep, it's gone.
I can't do it very well.
The paper's too flimsy.
I know it is. Okay. Can you guys see that cone in there that's forming?
Yes.
You guys get that? So we're going to talk about taking cross sections today. We're going to talk about what happens when you rotate that around. Rotate that around and get some kind of a shape to form on it. Now we're going to have different cross sections that we rotate to get different things. How many of you guys have seen like those, sometimes they'll have them at like a wedding or something like that, but they have the little bells that kind of fold out and around for table decorations sometimes, you know what I'm talking about?
Yeah.
Okay, some of the girls are shaking their heads yes, the boys are oblivious, it looks like. Okay, they have like these bells that kind of, they're flat like this, and then they fold out and around and they form that shape sometimes, so there's things like that. I wish I could, listen, if any of you guys ever go to a wedding sometime and you see one of those bells, hike it for me, because I want one of those so I can show that, okay? You know, some of you know stuff.
Yes, we steal stuff.
Yeah, they won't care, they're too busy getting stuff from other people. I'm sure they can part with one bell, right? Yes? Okay. All right, so here's the deal. Question that we're going to look at today is this. How can you create a solid of revolution? Okay, and it's exactly what we were doing. We're taking a flat piece and we were rotating it. We're basically taking a two-dimensional figure and rotating it so that it forms a three-dimensional figure. So really what we're doing, kids, is we're saying, okay, how do you take something that's a 2D cross-section from last section and turn it into something that's now three-dimensional after you rotate it, right? So this really isn't that bad of a section. It's pretty darn easy. Kind of like the last one. Goals to answer that question, how do we create a solid of revolution? First thing we're going to do is sketch and describe solids of revolution. Okay. We're going to talk about surface areas and what again? Volume. So as that's the case, you're going to want to be searching some of those formulas again. And then we're going to look at solids that are formed in the coordinate plane and then rotate some stuff to see what kind of 3D stuff we get there. Guys, I don't know what your plans are for next year. How many of you guys are planning on maybe taking calculus next year? Okay, I got to be really honest with you. This concept comes up a lot in calculus right here. So the idea that you get a background in this a little bit is going to help you moving forward. You'll have a strong foundation about what it means when you start integrals next year in calculus if you take it. Okay? So, first thing that we have here, kids, what is a solid of revolution? And it says a solid of revolution is a three-dimensional figure that is formed by rotating a what? Two-dimensional shape around an axis. Okay? It's kind of like saying, here was my axis of rotation. We might have a shape on that right here, and on that On that axis of rotation, you are simply going to rotate it around this axis like that. Okay? You're going to rotate it so it forms a shape. Okay? We're going to talk about axis of revolution. And an axis of revolution is the line around which the shape is rotated. Okay? Up here in this one right here, in this example right up here, that vertical line, any line that you rotate around is going to be considered your axis of rotation. Alright? So anytime you rotate around some axis, this is considered an axis of revolution or an axis of rotation, if you will. Right? Surface area, we've talked about that before. What kind of unit is surface area going to have in the end? Yep, number of square units. So I'm just going to write over here, it's the number of
Square units.
okay, and then we need to understand volume again. Okay, and the volume is going to be what?
Cubic units.
Yep. Okay, so it's going to end up in the number of cubic units, all right? So guys, when you're doing stuff like this today, make sure you're paying attention. Are we still dealing with area or are we still dealing with volume when we go through this? So let's talk example 1. Guys, if I had a rectangle adjacent to an axis of rotation here, it says sketch the solid produced by rotating the figure around the given axis and then identify the solid. Well, I don't know. Here's your rectangle. If I start rotating it around, what's it going to form?
Cylinder.
It would form a
Oh, bro.
cylinder. Okay? So I'm just going to sketch that. Here's this rectangle.
Yeah, mine for sure.
Okay, here's this rectangle, and it's just going to form a cylinder. I'll do my best to draw a cylinder. Maybe it looks like this, but I want to show you this real quickly.
I didn't do it.
Okay?
I didn't do it.
How'd I do
I don't
on my
know.
cylinder?
I don't even know how to draw.
So again, if I have a rectangle and I'm going to rotate it, which direction, kids?
What's that thing?
This is just going to rotate around the axis. So here's your rectangle again.
Wait.
You start rotating this, what's it going to form if I start going really fast?
Dude, a cylinder.
It's going to be a cylinder, right? It's going to be a cylinder, isn't it?
Yep.
Okay, and I'm going to kind of draw this cross section in here in a different color like this. So what's formed here, it kind of comes from this axis of rotation right here in the middle. Maybe this was my rectangle right here that got rotated. But guys, if this was my axis of rotation right here and I started spinning that rectangle all the way around, wouldn't that just go ahead and form that three-dimensional figure then? It would, wouldn't it? Again, if I start rotating this inside there, it's just going to form a cylinder, right? Okay? Guys, I gotta be honest with you. Most of the things that we do if we're rotating, what shapes are typically rounded in? Are you going to get a rectangle when you rotate it? Probably not. It's probably going to be some kind of a cylinder or some kind of a cone when you're all done here, rotating stuff, because those are the types of shapes that are round in the end. Okay? You might get a sphere if you start rotating circles and stuff like that. All right, let's take a look at the second page here. The second page, I think, does a really nice job. Does a really nice job of talking about this. Okay? Again, in this example right here, when I take this triangle, kids, start rotating it around here. Start rotating it around, rotating it around. You see your cross-sectional triangle right here? And that's getting rotated. As it gets rotated, what's forming here, kids, around that? There's going to be a cone in here, okay? So that's what we're trying to visualize here. So, what we want to be able to do then is understand how to sketch a two-dimensional shape and an axis. So in other words, saying, well, here's your flat surface, rotate it, what do you get? They want you to go the opposite direction, okay? So, over here, it says sketch a two-dimensional shape and an axis of revolution that can form the grain silo shown below. Okay. Well, this grain silo is round, isn't it? It's like a cylinder with a hemisphere on top of it. If I had to ask you guys how to draw a two-dimensional figure and an axis of rotation to create that three-dimensional silo, where would your axis of rotation go for that silo?
Right in the center.
Go right in the middle. So if you guys can kind of imagine this, if I would draw a line right through here, like this. Isn't that kind of my axis of rotation in the middle there, kids?
Yeah.
Okay? So if you can kind of divide this up into some kind of a symmetric figure, cut it in half, however. Guys, do you see the shape or the part right here that I would start rotating around this axis? This is really the shape you're going to rotate around, isn't it? Isn't it? And if I start rotating this whole thing around, what's it going to
I
form?
know what shape it is.
It's going to form that whole silo, isn't it?
Yep.
So kind of what we get for a sketch is something that looks like this. Here's my axis of rotation. We're going to rotate around that vertical line like this. And the cross section that we're going to have to rotate would be, this would be like the bottom, like my radius down here. Then it's going to go up. Tell me what to do about here, kids.
Start rounding.
Start rounding at the top. Okay? If I would take that and rotate that around that axis of revolution right there, what's that going to look like it forms when you're done?
Silo.
Yep. So that's what that's going to look like there. Okay? So what if I had, say, a ball? A perfect sphere. What would that look like if I wanted to draw an axis of revolution and its cross section for it? If I wanted to draw a ball, tell me what to do. A ball, you know what it looks like, three-dimensional, right? Here's my axis of revolution.
Just draw a circle.
I'll rotate this way. Half a circle. If I take half a circle and rotate it all the way around and out, it's going to form a ball like that. Very good. Okay. All right. Again, and I don't think that this is too earth-shattering here. I
If you
think
happen to have a flatbed truck with Benton County plates, you have your lights on. Flatbed truck with Benton County plates, lights are on.
okay.
No, the motor's anything.
All right. So example 3 is where things get going pretty well for us right here, and I like this example right here. This is really kind of the focal point of everything that we're going to be doing. So I might put a star by example 3 and say, all right, this is the part that's important. Okay.
All right.
First things first. This time, instead of my axis of rotation being a vertical line, my axis of rotation is actually kind of a line. Horizontal, okay? So you're going to kind of rotate up and around like this, okay? That's okay, all right? Let's get some dimensions in here. I'm going to call this 7 inches. This is 24 inches. I'm going to call this 25 inches up here. Okay? And then furthermore, let's assume that this is a right triangle, all right?
Oh, whoa.
Okay, first things first, sketch and describe the cell. I'm not the greatest at sketching stuff, I'm going to be very honest with you. So if you'd rather describe this in words, I'm A-okay with that, okay? So when I rotate this, what's it going to form? It's going to form a cone again, isn't it? It's going to form a cone again. So a cone will be formed. I'm going to do my best to draw my cones, so don't laugh at me.
Chase, you're supposed to be nice. He said don't laugh, not to.
Okay, now what do we need to find, kids? Surface area and volume. You want to do this by memorizing formulas, or do you want to jump in and plug numbers into Google?
Jump in and plug numbers in.
Okay. So what we're going to need to know, kids, is we're going to need to know a radius and we're going to need to know a height. Now, guys, this is kind of my axis of rotation right through here again.
Be 7.
What would my radius be?
7.
Yep. And then how about the height on this? And be careful, when we talk about heights, we're talking about typically heights on the interior of these 3D
24.
shapes. Height would be 24,
You don't
okay?
like that.
So the slant height on this would actually be what value? 25, right? So let's jump in there and do that. I'm going to find a cone, surface area for cone. So surface area of a... All right, kids, what do you want to put in for the radius again?
7.
7. And what did we say the height was there again?
4.
24? Okay, so what do we get there for surface area, kids?
703.7.
Yep. So we're going to get 703.72 for my surface area, and that would be square inches, wouldn't it, kids?
Yep.
Okay, so the surface area,
What is it? It's a hot flipping
I'm going to abbreviate that surface area as, what was the value again, kids?
703.7.
72?
Yeah.
And that would be square inches, right?
Yeah.
Okay, so we're good there. What else do we need to find, kids? The volume? Yeah, I think from what we have in here in surface area, we should be able to drop down here from this little menu right here and be like, okay, I want the volume now, and click on that. And then put our values in. So what are we putting in value-wise there?
7
and 24.
7.
Oh my god.
Anybody have a value after putting that in?
2.
Hmm. 1231 point. I didn't touch the rest. Okay, perfect. So Kylie, 1,231.25. Okay, so I think that what you're looking at, because I think you kind of get this right here. Again, typically what you're going to form is going to be a cone or a cylinder for most of the stuff. Okay, there'll be the occasional sphere that shows up in some of these rotations. And then you might have the odd shape like a silo or something that you have to sketch. All right? So guys, I think you've got a pretty good understanding of what's going on here. So what I really want to make sure we know how to do is what's on this last page. And on this last page, kids, if you can understand this, I think you're going to be in great shape for this section. So, first things first, anybody need more time with page 2? Any questions about anything that's on page 2 right now? Again, you're just simply taking the cross sections from the last section and we're starting to do what now, guys? Rotate them, right? Kind of working backwards, going from 2D to 3D. Last section we were going from 3D to 2D. All right, let's talk, kids. Let's talk. Oh boy, here we go. So we're going to start talking about forming a solid of revolution within a coordinate plane. But before I can even do that, kids, I need to first of all form a cross section within my coordinate plane. And in this particular example, it says to do what?
Sketch and describe the solid that is produced when the region enclosed by X.
X equals what?
0.
0. Now guys, if graphing is a little rusty right now, decimals is always a great help, but X equals 0 is simply the y-axis. So I'm going to draw a line on my y-axis. Is that okay? What color? Let's get a little goofy with colors today. How about, there we go.
Neon green.
Neon green today?
Yeah.
Is that okay?
Sure.
All right, let's go with it. Gnarly. X equals 0 is right there. I'm going to make a note of that. X equals 0 is that line right here. What else do we have, minions?
Y equals 0.
So if X equals 0 was the y-axis, Y equals 0 must be the
X-axis.
x-axis. Gnarly. Okay, there's that line. Y equals 0. Okay, kids. What else?
Y equals X plus 2.
Y equals X plus 2. Okay, and then we've got to put one more in there. I forgot to put one in there. We'll put that in there. What's X plus 2 look like, guys?
Go
Uh,
to 2
go
and
to
just start. Go.
Start at 2.
Yes.
No problem. This will work. Y-intercept is 2 right here, right?
And you go up 1 over 1.
Slope's right there.
Perfect point.
Okay. Actually, we don't need to add another one to this. So it looks like my line for this is,
Whoa.
right? So kids, this is the line. Now kids, those three lines that are graphed in green right there, do they make a closed shape anywhere within your graph? They make a triangle. And where is that triangle at? It is right there, isn't it? So I'm going to shade this triangle and say, okay, here's my triangle that's formed. Okay, so the cross-sectional piece that we're going to end up rotating is what shape?
Triangle. Or right
Triangle.
triangle.
It's a right triangle furthermore. Okay? That's the one that's going to get rotated. All right? So make sure you've got that down first, and we'll talk about after I've got that in there. Now again, if graphing's a little rusty, jump into decimals, just confirm some of your lines. Okay? So it says right here, after I've done this, it says find the volume of the solid after we rotate it around which axis, kids?
Wow.
Going to rotate around the...
X.
Okay, so there's going to be rotation that takes place moving around the x-axis like so. We need to rotate that direction, right? Okay? Now when I rotate this, that's going to be like that sideways cone. But guys, if I rotate up and down, what's your radius going to be in this situation?
2?
2. Your radius is going to be 2 when I start rotating this way. How about that interior height from the point of the cone to the center of the cone when I rotate around the x-axis? That's also going to be 2, isn't it? Okay? So in this situation, we know that the radius has to equal 2. We know that the height has to equal what after I've done that part? 2. And if you're having a hard time visualizing this, this is what it's going to look like. Here's your little cross section that you have in here. This is just going to get rotated around this direction, kind of like this, and this is the cone it's going to form. These are the two triangles that get rotated around to form this. So the radius out here again is how much? That'll be 2. And what's the height down here on this cross section? All right. Maybe you guys can punch it in volume of a, but if you did, I would know the volume of a cone is pi times radius squared times height all over 3. This would be pi times 2 squared times the height all over 3. That's the formula for the volume of a cone. You guys are probably already ahead of me. Have you punched that in, Natalie, at all?
8.38.
8.38? Okay, what type of unit should I attach to this given what we just did then?
Volume. Oh.
8.38 cubic units. Yeah, I mean everything here is just one, this is 1 square is 1 unit. So when we start talking about what will the volume be out of this coordinate plane, what'd you say again, Gibby? 8.38?
Yep.
You just put 8.38.
Units.
Yep. Awesome. Okay. First things first, do you guys understand how I graph my lines in there? That's the first question. You understand all the lines that were in there? The second thing then is like, okay, can you find the closed shape that those 3 lines enclose? In this instance, it was what shape that was enclosed here? Triangle. We're saying, okay, now we're going to rotate that around the x-axis. So if I rotate around the x-axis, we have to understand the radius would be 2. The height would have also then been what? 2 in there, because this is like a sideways cone. It's not standing up. Put that in your calculator and you get
8 points.
Okay, now my suggestion again, kids, if you're rusty on graphing, go where?
That's.
Yes. Okay. All right, let's do this. I do have a short quick quiz on this that I'd like you to try and see where you're at with some of this stuff today. So I'm going to hand that out. The new online page is there, and the new online page will not be due until Tuesday at 10 o'clock.
No.
Is that a copy over?
No. I was drawing a representation of yours. I was drawing a representation of yours. Oh, we finished it. Now we keep it on the table. We can turn back and have it.
Okay, sounds good. I'll get that in there, okay?
But you can still see it.
Good. So right here. Oh, actually, right here.
You can erase it.
Did everybody get one there?
All right, let me get the CODIS here.
No, I didn't do it. You see that in your
Sorry, teachers. There's also a white Ford, V6 Ford pickup in the north parking lot with its lights on, a white Ford pickup in the north parking lot with lights on.
Well, it is Ford.
They did that on purpose,
Who did that?
Logan. And you think the other one was harder?
Really?
Dude, just fall off like 2 days ago. 3 days.
Is that little problem solved? Or are they still upset with each other?
I don't know.
I got a class.
Oh, cute.
When was that fight? Last Friday?
No, it was Monday.
this week.
Tuesday.
Tuesday this week?
I got a class. You think that would be what happened?
Are they back today then?
Yeah.
What's that?
Dude.
I think you guys have that in print. I didn't.
Oh,